Yeah, I already shared it via your email. Please check it. The first two lines will be enough. Yeah.
You shared it to my email?
Yeah. Your email.
Let's see it. Okay, just a moment.
Have you got it?
Is it this one? Let me just show this.
Yeah. That's it. So may I go on? May I continue, Daphne?
Yes, just let me know when you want me to continue. You can go ahead. You can let me know.
Hello?
We can hear you as right.
Okay, thank you. Thank you. So thank you, everyone. So as I have introduced myself, we are engaged in so many projects. One of them is this one, funded by the IPAR, which we are very thankful. So the topic, you can go on. Next slide. Next slide, please. Now slowly. Go back, please. Back. Back.
Back or in front?
Yes. Yeah, this is one of the projects we are working on. So the overall project was to study the inclusiveness and diversity of AI landscape, the overall the data, the systems, the processes, and the people who are engaged in those the overall ecosystem as a player and as a user. So this problem, you can go on the next slide.
Astrid, your network is a bit unstable. You keep coming on and on.
Yeah, we have gone through these steps during the project initiation. So we have tried to analyze what are the scopes we have to go through, scope and define the methodologies and the finding the research gaps, what are there already done in the area using different African indigenous languages. And we come up with 3 different set of problems within one of the problems. We come up with 3 problems. So these are the processes where we went through. Go ahead, please. Go ahead. Yes, these are the processes we have went through during the brainstorming session. We have tried to articulate the problem clearly. Then we come to know that there are so many things. Defaman, you go back. You went back. Go further, please. Yes. So here we have got different data that are based on, what are the AI ecosystems that we have to consider, and what are the indigenous language in their statistics, on the ground, so that which African language are going to be, we have to focus on, and which African languages are have, different AI tools and researches and policies, regulations, all those things we have try to identify. Go on, please. Go on. Go on. This I already said. Yes.
Is this what you needed? I think we lost you again. Hello? Is there anyone else? Please, panelists? I think we keep losing people.
Hello, you are hearing?
Astrid, your network is
Yeah, okay. Now you can hear me?
Yes.
Hello?
Yes, we can hear you now.
Okay, thank you. So these are the problems we have framed, okay? So mapping study we have already done using African indigenous languages in the AI ecosystem. We have mapped, okay, which African indigenous language has been involved or used, applied in any of the AI ecosystem components. That is the first one, which we got to very interesting results. Then the second one, we have investigated the degree of diversity and inclusiveness of the African indigenous language in each of the components, as I've said, diversity and inclusiveness. We are focused here the diversity and inclusiveness after mapping the language with the AI ecosystem. And finally, we want to portray what are the challenges that are existing based on the results we have obtained and what should be done in the future. So through these three dimensions, problem sets, we have already finalizing more than 80% of the topic I want to.
So maybe I can just ask you
share within 5 minutes. Thank you, Devin. Back to you.
Can I have a question here? On your first research question, attempts to link which African and local language have been used in the various levels and entities. So maybe what have you been able to find as the dominating African local language?
I'm not listening you clearly. Sorry. What did you say?
Is it my network? Am I the
a
one
bit shaky. The sound from your side is a bit shaky. I don't know. Is it from my side or?
It may
Now it's okay. Now it's okay.
All right. I was asking, as per your first research question, what has been the predominant local language have you found to be used in the various levels of the AI ecosystem?
Maybe you can type it. I'm not able to hear you.
Okay, I'll do that. So should I continue? Maybe because we are 30 minutes in, I'd like you to maybe summarize, because we have a couple of other researchers. Is there anyone else? Is there another panelist?
I'm not listening. Your sound is a bit shaky and interrupted.
Benjamin, Endeavor people, should we first leave abstracts and get someone who's a bit clearer?
Yes, sir. Hello?
Abstract, I think you need to find a better connection. You keep going off. I don't know, is there someone from Dr. Joyce's project from the AI lab who's going to present as we wait for abstract? Yes, All right, please go ahead and let us know who you are, what your project is about.
Yes, hello. Can you hear me, Daphne?
Yes, I can.
Yes. So my name is Sulaiman Kagumere, and I work with the Makere AI Lab with Dr. Joyce Navende, and the team we've been working with on this project. We have Dr. Peter Navende and the rest of the team. I think some of them are in the chat. I mean, in the session here. Yeah, yeah. So I'm going I came in for Dr. Joyce today. Yeah. So yeah, I don't know if I have to. Do I have to share my slides? Cause can I share?
Yes, please. You can go ahead.
All right. Thanks.
All right.
Can you see my screen, Daphne?
Yes, I can.
Yeah. So the project that we are working on is understanding gender biases in building automatic speech recognition systems in the African context. And I said I work with the Makere AI Lab, part of Dr. Joyce's team. Yeah, and Macon Lab, of course, from Makere. Um, so basically, to start with, what we are looking at in this project is so we've been looking at the Luganda language from Uganda. Uh, so the problem is the Israel systems. That's I'm assuming that we all know what ASR is, like automatic speech recognition systems that can be able to convert spoken language into written text. So uh, the existing systems for Uganda, basically, what we found out. Sorry for the noise. So what we found out is these systems they tend to have these biases, gender biases, between males and females. Actually, specifically the existing ones, they tend to recognize I mean, they tend to work more on the male voices than the female voices better. And this is a problem actually wanted to like look at why they have these biases. Uh, then the gender bias, and then there's of course the age bias we find in these models. What I mean, these systems work well for some ages. I mean, age groups and accents. You know, we have different Luganda accents across the country. We have from the west, we have from the north, central region, then we have from the east also. So there are different accents of Luganda, but these models tend to work better on the central region accents better than the other. So we are trying to find out why. I mean to like to uh, to try to mitigate these biases in these systems. So that's one of our actual objectives. One of them we are to like first understand what these biases are and why they exist. And so we did some literature, I mean some systematic review there, and then wanted to like build some framework or some guidelines to mitigating these gender biases in these Luganda systems. So there are some of our objectives we are looking at. So basically, from what we reviewed, I mean, yeah, from the existing literature, I found out that there are for Uganda there are like three biases. We have to look at this. One of them is gender, and then we have age, and then accent. So there are the biases that do exist in these systems that are already there for Uganda. So what we did, we 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 had a plan of collecting a gender balanced data from the regions I mentioned, from the central region, western, eastern, and northern. These are like they have different accents of Uganda. So the data we collected is you can see in the table below. So collected like more hours than you can see in this table, but these are the ones the land experts had they are proved to be like the right I mean the right recordings for Uganda that we have recorded. So there are some, I mean, there are the approved recordings from the entire data recorded. And then, yeah, so what I'm going to basically look at is how we use this data to like to fine tune these models and then right produce these errors between the genders, male and female, and of course the age and accents. So these models can, I mean, the errors can be reduced. So we basically looked at theory state of that models as stated in here, and then what we did first was we did some pre-processing, of course, some silent streaming from the end and beginning of the recordings. And then we did some denoising using some state-of-the-art model called DMAX model. Then, of course, we did some text reprocessing like lower casing. Then the other thing we did, because we got this data from different regions across the country, found out that some age groups, for example, 50 and 59 and then 60 and above, these people are like very few can like speak Uganda from residents that outside the central region. So we combine these age groups from 50 then and above, and yeah, we combine. So what we did, of course, for training, we split this data into training, evaluation, and test, and then the base model that, of course, among the theory that we considered was the first model that have to work. It's one of the state-of-the-art models that worked for us perfectly. So we trained for 100 epochs, like on our data, and then so for the so what we did first was to evaluate for gender bias from our test data, the gender balance test data, because we had try to balance the genders in the training set, validation set, and the test sets, so that we at least eliminate that bias in the data. So what we got is actually this, as you can see in the table. So the errors, the lower the better, right? Like the word error rate, you can see for males it was around 5.3, then for the females it was around 5.9. So, but when you look at the existing models, the actual you find that we found that the errors for male it was at, I think, around 25, and for males it was around 30. So this was a great improvement because of the gender balance data we collected. And then for the age, you can actually see for the age groups, we had around four age groups: 18 to 29, 30, 39, 40, then 50 to 59. So we from this table, they don't look like they are the same areas, but they are, you can see there is around 12.3, and uh, it might look that okay, it's like so high, but when we look at the existing models, how they perform, maybe I didn't add the graph for that, but when we look at how they perform on this data set, it's actually way more than 30% for all these age groups. Uh, so you can say what balancing the genders and in your data collection, what it can do to reduce the biases, the gender bias, the bias for the gender, and then the biases for the for the age groups for each gender. So for the accent, you can say with the model performed for all the regions. We have the central region. Actually, the model performed better on the eastern data more than even the central data. And I think the reason for this is because the eastern Uganda is actually similar to, okay, it's somehow similar to the central region Uganda. That's why the model, the model, that's one of the reasons why the model performed actually somehow better than the central region. Of course, for the northern region, the accent is not so similar to these other two regions. That's why it's still it shows that it's around 8.1 word error, but it's still low, right? Because 8.1 is like a good error rate when you compare with the existing ASR systems for Uganda. Yeah, then so this is what
sorry, I can stop you there. Maybe you can just give us what your findings were, and then we can just have a back and forth Q&A on some of the challenges we faced and all that, because there's another panelist also has to share his work. So we can just stick to what your findings, your final findings were. Sorry for cutting you short.
Yeah, no, it's fine, Yeah, so so what I can say is so building like so okay, maybe I don't know if Dr. Peter is in the call. Maybe he can add his voice on this. So what I'm saying is
Okay.
yes, Doctor.
Okay, yes, this is Dr. Peter. I think to conclude here, I think as Sulaiman has presented the results, our findings, I think, validate some expectations that within closely related regions, in other words, regions where languages are a bit closely related, you will not see much differences in the performance of the automatic speech recognition. So that's why you see the northern region, mostly the indigenous languages there that influence the accents of the Luganda language are kind of relatively a bit apart, considerably apart as compared to the central, rather the eastern, and maybe the western region. I think the languages there may be a little bit closely related to the language of study here, Luganda. So that's why when the evaluation is done, I think it validates that expectation that in northern Uganda, I think this is the Nilotics group, Nilohamites group, you tend to find on accent, the models, if a model was trained on Luganda, then the accents from northern Uganda, the model may find it more difficult a bit, as seen here. Yeah, but then that of course is important, that we really need to factor in or to incorporate more data sets from some of these regions which are a bit apart, which are influenced by languages that are a bit apart from the language that we are studying here. I think generally that is the key finding and the key implication from what we have established right now. Thank you.
Thank you so much, Dr. Peter. For that insight, it's very interesting to see. In the morning session, there was a question on how one of the challenges we face as Sandbag with regards to training our models with data sets. So you'll find that, so for instance, like Midbar, there's always there's been a challenge with the dialect of the language in Midbar. There are different people, different communities within the Western region that speak Midbar differently. So this, I think, also kind of contributes to gives insight on how inclusive or how wide we need to train ASR models in order to cover a larger scope of people. We'll have a Q&A. I don't know if India was going to give us some more time because I see we're already about to reach the 3 p.m. mark. Benjamin, India.
So yes, thanks for sharing that insight of Lugbara. Yeah, indeed, languages have dialects, and I think the key point there is to ensure that the data sets capture that kind of diversity. I think this is one of the, you would say, one thing you can try to consider as a checklist when you're trying to build a model for any language or for any automatic speech recognition model for any language, to see whether it checks out on that kind of diversity as well. Thank you.
All right, thank you so much. I think Dr. Waleni from Deborah Marcos, you're up next. You can share a brief about your project, the objectives, and your findings, so that we can have something more interactive with the participants. Yes, please go ahead.
Hello, can you hear me?
I can hear you loud and clear.
Okay, thank you very much. My name is Walelin Toabe from Deborah Marcos University. Our project is a multilingual neural machine translation for low resource language with gender-based detection and mitigation for English to Amharic, English to Tigrinya, and English to Afan Oromo language. This Amharic, Tigrinya, and Afan Oromo language is the most widely spoken language in Ethiopia. So out of this is a large project. So we classified our work into different subsection. So now I will present one of the main subsections, that is gender-based evaluation in machine translation for these 3 languages. Okay, so I will start from the background and motivation to give you some highlight about the gender bias. So the advancement of this neural machine translation, as you know, have enabled more natural and fluid translation, but still there is a problem in societal bias and some,
I think we've lost you.
garbage. So wherever we have data, biased data, the output also biased. So the existing problem, one of the available machine translation tool is Google Translation. So we see that maybe you can see in your own language there is a gap. There is a clear biasness, especially for women related to the occupational words. So this is one of the issues. This is the things that we motivate to solve and somehow to reduce the biasness of the machine translation. And this is one of the top industrial issue. To give you some highlight about these three language and about the multilingual machine translation, some languages have few relative to compared to the others, the developed language, the existing data set is small. So this one of the advantage of multilingual machine translation, neural machine translation is they share the like different neural machine translation techniques. So that's why we prefer this multilingual technique. Anyway, you can see the left side, the number of population spoken. Amharic is the official language of Ethiopia, and English, as you know, it's worldwide known. So our data will be English-centric. That means English to Amharic, English to Tigrinya, and English to Afan Oromo. So the result also just from this four language to either of the next four language. To give you a highlight about the script also, Amharic and Tigrinya use Ethiopic script. We call it Giz script, or sometimes we say Fidel, as you can see on the screen. But Afan Oromo use Latin alphabet. They call it Kube, Afan Oromo. So to show you the clear from that, I should take some example. One example to see the biasness of the Google translation is accessed in January 28, 2024. Since we translate English to Amharic, maybe it's difficult for non-speakers of this language to understand the word, but you can see the picture clearly, how the biasness after translation is look like. The first, the doctor was female, but after translation becomes a male. So this is one example just to show you the existing problem. Yeah. In order to solve this problem, we analyze the currently available data sets. So one of the techniques to solve this is first we should prepare a benchmark data set, benchmark data.
Maybe we lost you again.
Different techniques, and we publish in high impacted conferences the output. So I will show you the steps, and just it's very important to see especially the pronoun, the gender. Amharic especially is gendered language. All nouns, pronouns, words are gendered, so somehow it's difficult to understand. That's why it takes long time to analyze, and we bring it to solution. Anyway, you can see that for the left side, the English pronoun. So you can count it you, the you pronoun 1, 2, 3, 4. So to say a plural, to say for female and to say for male and also for respected, we call it differently. That means it's very specific to call one and other so that's why one of their pronoun, the nature of the language is different from others. So this is example for Amharic actually, but for other language, Afan Oromo and Tigrinya also the same, like that. So all, as I said, the occupational words, the thing is that we give emphasis, because there are different sources to be biasness.
Voice?
Sorry.
Is it only with me or?
Hello. Can you hear me?
Yes, we can hear you. I think
Okay.
someone is trying to.
Okay. Okay. So we we give emphasis on occupational words because based on our study, we got is occupational words have a big biasness problem in machine translation. So if we solve this problem, the biasness of the machine translation can be reduced in huge number or huge percent. So that's why we focused on this. So we collected the occupational words in each language and translate to each language also. That means English to each language. Finally, we evaluate after translation using this Google Translation, and from one open source NLLB. No language left behind. We used these two existing translation tools. So to give you another technique, just after we produce a benchmark data set, the next step is just to build a detection and mitigation techniques. So one of the things is just automatically identifying a sentence or categorize a sentence into male or female, like that. So to use this first, we should bring a code that extracts the pronoun from the sentence and also the occupational words, whether female or male. So based on this technique, this is one technique, not the final, we can categorize or predict one of the technique to be a sentence is for male or female. So anyway, this machine translation tools. So the result, as you can see, Afan Oromo, it shows 93% is of the translation, the test result is gender based, and Tigrinya 8%, Amharic 72%. So all are above 70. It shows that it's a big problem with our dataset. Our dataset size is 2,400 gender balanced sentence. It contains all occupational words that we used in Ethiopia Civil Service Minister. We collected from that and we translated for each language. So just to illustrate in a graphical form, this is the result after the evaluation. So this evaluation is done by the linguistics experts from each language speaker. Yeah, it's a different way used also. On the way, we evaluate also the accuracy of the machine translation, because the accuracy of for low language, low resourced language is very low. So this gender biasness also can be one of the reasons to be low. Just to show that on the way we evaluate based using our test data set. So I think in order to save time, this is the main thing that I want to share you. So this is the result. So thank you very much. We can continue for question and answer.
Great, thank you so much, Dr. Ali. So maybe I can just start off the question session. As I get some from the participants from the chat section, or I can allow for a chance to speak. The first question I have, what are the main challenges you have encountered in addressing the data bias in your work?
So can you repeat?
What are the main challenges? So this is for you, Dr. Peter, and the people from ERA, but then Dr. Asrat as well. I hope you're on the call now. I can hear you. What are some of the challenges that you've faced in addressing gender bias in your work?
Okay, can I start?
Please go ahead and start.
Okay, thank you. The main challenge to do this is the lack of previous work. especially in the gender biasness of the low resource language in Ethiopic. Our work is the first and the pioneer. So it is very difficult to get the previous related works and also the data set, especially to get the data set. We didn't find any collected occupational words for each language. So first we should collect occupational words, then translate to each language. And so this was the main challenge because this is the root solution, the root problem, and also the solution also should be collected, the words, the occupational words, and make it balanced data set for the future. So this was the main challenge. Thank you.
So you did that collection manually. That's
Manually, yeah. We did data collection manually by hiring different linguistics and fluent speakers.
for those 2,400 sentences.
2,400 sentences, the total.
All right. All right. Anyone else want to share their challenges that they've experienced?
You talk with me? Sorry.
No, anyone else from the Gray Network can go ahead. All right, we have a question. Is Dr. Ashraf, are you still on the call? Or anyone from the AI lab? All right, I don't hear from him. I see Byron's hand is up. Yes, Byron's hand. Please, Byron, go ahead and speak. I need to allow them. All right, can you talk now?
Thank you. So I'm asking, wouldn't it be easier to solve the gender biases by mostly getting female data?
Dr. Walagi, have you had a question?
Okay. Yeah, I think is it possible to solve the gender bias by collecting female data? Is that the question?
Yes.
Okay. The data set should be balanced. This was the problem. The problem of the gender biasness in machine translation, we see it from the data set. The available data sets, the use it for training is not balanced. So this was the main problem. So our task or the future researcher also should be focused and just take into consideration the collected data set is whether balanced or not. So collecting the only females data is not the solution. The solution should be balanced. So our data set is I said 2,400. That means 1,200 for male and 1,200 female. Totally, the male and female in our test data set is balanced. So the final goal is balancing the machine translation data sets. This is our test data set. So after balancing, we tested the result based on this test data set. So this is, thank you.
Great. Sulaiman, are you still on the call?
Hello.
Okay, yes, Dr. Peter. Can I just echo my question?
Yeah, so you talked about challenges.
Yes, challenges you faced in addressing gender bias. I don't know if you also want to speak to Byron's question on why not using female adolescents solely as training for training. Yeah.
Okay, so in our case, of course, in addition to gender bias, we are looking at, of course, we try to collect data from different locations of the country as well. And there, of course, in that case, we have the challenge, of course, has to do with the logistics, maybe to try to collect as much data as possible. So maybe we may be limited in we are limited in what we are able to collect. So, and also for the, you probably may not be able to cover as many or completely cover different all the different let's say for accents, all the different accents that are possible, simply because of the participants that are involved. Maybe you're likely to get more associated with one accent and less and few associated with another, just because of the distribution of some of those language dialects. For the case of solely training on women voices, I think that is really an interesting idea. I don't think that's something that should be much of a challenge. I think under experimental settings, we have data sets with women voices and tagged as such, as with women or female voices. And I think it's a matter of just separating them out and evaluating, experimenting and evaluating and seeing what the performance of the speech recognition model does. I think, but of course, in some cases, we found that the models are performing very well on one gender as opposed to another, which means that most likely there was in the data set more representation for one gender as compared to another. So, of course, what that means is to try to get as much data for the other gender as well. And I think the process is a bit straightforward. I think that's what I can say. Thank you.
Thank you, Dr. Peter. I'm just going to have a last call. It's actually on there are a couple of questions in the Q&A section that I want to read out. So whoever feels compelled to answer, please just go ahead and unmute and let me know. So the first question is, what strategies did you use to identify and mitigate gender bias?
Hello.
Hi, Ashford, can you hear us?
Your voice is not clear for me. The others are okay, but yours is
Sound
shaky.
clear?
Now it's better.
All right, so I'm just going to go to the Q&A section. Unfortunately, we lost you along the way, but maybe we can have a recap and maybe discuss this. So what strategies this is Dr. Ashrat, Dr. Walengin, and Dr. Peter. What strategies did you use to identify and mitigate bias, gender bias in the training data? So maybe, yeah, you can, whoever feels compelled can go ahead and share the experience of that.
I think maybe if I can go on that one. Yes, so if you are established bias, as we've done in some of our data sets that we've evaluated, I think the obvious approach to try to deal with that is to collect representative data for the other gender that is involved, to try to deal with that. And So beyond that, there could be a number of techniques under constrained settings. Maybe if it's a bit difficult to collect it, you could go ahead and try to create maybe synthetic data from what you have, just to give the model a chance to expand on the representation for some of the like the gender that is underrepresented. I think that that's what I see should be working as a mitigation, an underlying mitigation measure. Of course, it is important to recognize that these biases, it's important, first of all, to detect these biases, because sometimes they can pass undetected. So for the systems that we produce or systems that we develop, we must put some mechanisms of checking some of these biases. In some cases, we've used systems maybe ignorantly, without, maybe not ignorantly, but we think maybe they are good enough for the tasks they are developed. But after some time, some of these issues, they tend to be not to perform as desired. So I think that would be one key thing, considering that now bias is a sensitive thing, and it can have really unfair consequences for some of these systems that we develop. We need to establish mechanisms that can detect some of these biases. Thank you.
Thank you. Dr. Waleni, do you also want to share, especially because yours is very specific to this question? Hello? Can you hear me? I think we lost Dr. Waleni. Dr. Ashrat, do you want to also?
May I go on?
Yes, please go ahead.
Okay, in our case, remember that our work is SLR, Structural Literature Review. So at the beginning, what was the challenge we faced were basically, we much of the works done in AI are based on, what we call colonial languages, okay? North African indigenous languages that are, being used by the people of Africa, rather, language like French, English. So, we redefined our problem and redesigned our search strategies to find the appropriate data. And we have gone, so many rounds of searching using snowballing and other AI tools to clearly identify what should be, what kind of data we should filter. That was the greatest challenge. And even sometimes we know that the data is there. The data is there. In some of the cases we have involved in those projects, but they are not available online. So all these were the problems we have faced, and much of the data, as you said, are not online available, and some of them are, not reliable. So there were lots of challenges, not only in getting the appropriate data, but some of them are manipulated and biased. So we have tried our best to identify, filter, and validate the data. Whatever data I have collected, Dr. Bakal will validate, and whatever Nathaniel found it, we will validate. So this is how we went through the data pre-sourcing and filtering phases. Thank you.
So maybe I can just ask a follow-up question, that what were your variables for filtering? What was maybe like a checklist of things you are ticking off to see that you are validating it?
Hello.
Yes, Dr. Waleni, you're on, but I'm going to Dr. Ashra for a bit. Have you heard my question?
No, I didn't hear you. Sorry. What did you say? Sorry.
So you said you are validating the data, right, at the collection point, right? So my question is, what were the variables or like a checklist of what you consider like validated data?
Okay.
Yes.
Okay. First, what we have tried to set, those criteria. For example, what do we mean by African indigenous language? We have set criteria. So, okay. So there are languages that are, many African language individuals. So we set criteria, not only what we are speaking or the people of Africa are speaking, but they should be indigenous. They should came or generated from, before the colonial time. So there is time, there is indigenous nature. Okay. So these are the variables we try to validate. That's not the only one. The other one, we found out some tools that are developed by, non-Africans using African language. But at the same time, African researchers are not working on AI tools or systems or applications using their own language, but colonial language. So these are the different criteria we have used individually to validate the data. Some of them. Thank you.
Thank you for that. Next question is, what role do explainable methods play in addressing gender bias in AI models? What roles do explainable methods play in addressing gender bias in AI models?
Is it for me?
Anyone, any of the three project representatives can answer. Please feel free.
Maybe Dr. Walali.
I didn't hear you, Daphne.
Question?
Can you repeat? Yes, the question.
What role do explainable methods play in? Maybe the person who asked this can just elaborate. I can give you speaking rights if you just raise your hand. No, I don't see them. What roles do explainable methods play in addressing gender bias? Maybe I can go to the next one as we get to explanation. What ethical considerations should we prioritize when developing AI systems to impact gender equality? What ethical considerations should we prioritize when developing AI systems that impact gender equality? So, again, if you can just raise your hand, I'll give you speaking rights, and you're able to just ask your question the best way you can. Does anyone want to take that on? What considerations should we prioritize when developing AI systems? What ethical considerations should we prioritize when we're developing AI systems that impact gender?
May I go on?
Yes,
Hello?
go ahead.
Okay, thank you. In our case, one of our findings is categorized into who should do what. Okay, in the third problem set, which are presented at the beginning. In the third set, what we have identified is who should do what, because there is huge gap in the African indigenous language being used in the ecosystem. So if this continues, we are going to left behind. So one of the interventions that should be done is funding. The funding should be biased towards, gender, female. So we know there are so many, emerging young talents. So we have to support them to work on African indigenous language to develop, tools, applications, and solutions for the indigenous individuals. Okay, that's one thing. The other is platform. These platforms may include software and hardware platforms that are going to be used by indigenous, Africans to solve their own problems. Okay, so that should be facilitated somehow. Then the other is collaborative work. There are experienced researchers who have wealth of experience, global experience, and continental experience that should be shared, through mentoring, training, and other, collaborations, so that we be able to develop the next generation to solve its problem using AI. The other is very important for policymakers specifically, policies and directives that nurture and support, such developments. For example, if you take case in Ethiopia, the software, even though there are rules that can work on software, but that's not supported by policy, government policy. So there is no, platform, landscape, or ecosystem that can, be able to engage in those software development projects or activities that can, solve our problems. Okay, so these are the key 4 facets we identified. Thank you.
So just a follow-up question to you, Dr. Ashrat. I hope you can hear me. If I'm not clear, just let me know.
I can hear you.
In your presentation, as you are starting, what you told us that you did some preliminary research on which African local languages are dominant, right? So as per that research, which ones did you find were the most dominant or predominant languages used, let's say, by like Google Translate and the rest? Which ones do they actually pick up on? And do you even know like why that is it that there's like a sort of good setup in terms of policy, like you say, in terms of the infrastructure that's available within these countries that have dominant languages? Is there some sort of link in that regard? Yeah.
Okay, thank you. This depends on, based on our findings and analysis, this depends on the population, for instance, you can take the Chinese, took, the majority of because they are very huge in terms of, they are very large in number. So the statistics is biased based on their, solutions and platform they are using. The same is true in our case. So, for example, in Ethiopia, the Afan Oromo is the largest ethnic group ethnically. So in their region, they use it for education up to a certain level. So that language becomes dominant. But Amharic, much more population in all regions. So we have found Amharic, okay, highly used. Then the Swahili, okay. Then some language in the Zulu, like the Zulu in the southern part of Africa. So these are the language that we have found being used in a better way, as a matter of fact. Thank you.
I still have a couple of questions. I'll finish them and then close the session. How do you combat accented speech and code switching? How do you combat accented speech and code switching? Yeah.
I cannot hear you.
Sorry, I was saying the question is, how do you combat accented speech and code switching for those that are developing? I think this is for Dr. Peter. for your ASR models? How have you encountered that? And if so, what have been some of your ways to mitigate it?
Okay, so thank you for that question. I think the way it has been phrased is more like how you try to deal with accented speech and code switching. And anyway, that's how maybe I would have desired to understand it. But I believe it's what it should be like. I think it's basically you just have to ensure first of all, of course, for accents, that is natural. You recognize that there are accents for any language, and you just try as much as possible to, in your data, to represent those different accents. I think that would be the most direct approach to handling that. For code switching, yes. So this may relate to multilingual systems where you try to create models that are able to deal with multilingual inputs, where you recognize that inputs may be code switched. So there are contexts where there's a lot of code switching, but there are contexts where there's not a lot of code switching. And therefore it depends on the, where the models are going to be used. But ideally, you want to also detect the use of code switching in languages or in utterances, and ensure that you're able to identify that an input is code switched or not. So you can try to, for example, model for just that detection bit, that detection step, first of all, to see whether an input is code switched or not, and thereafter, if it is code switched, you can move on to identify which languages are in there, and after that, you can apply your recognition systems respectively. So I think for each of those, therefore, then for accents, you just try to capture as many accents as possible in your models, either when you're updating them, you're maintaining them, or at the start when you're developing them, you try to incorporate as many accents as possible. And then for code switching, I think that relates to a detection and identification kind of task before you can move on to do the main task, for example, in our case of automatic speech recognition. So we have had cases where some of the sentences that we collect are actually code switched, and we have had to label them as such, just specifically for that purpose, that at some point we will have to either model them under a multilingual kind of setup, or just try to identify them to create identification models that indicate that they indeed code switched, and then thereafter we can proceed with other processes. Thank you.
Thank you. A question to the three of you. Are these data sets publicly available, or I'm not sure, for anyone interested in accessing them?
I think for us who are collecting, probably in my case, the projects I've been working on, in most cases, the data sets have been openly available, and I want to believe that in this case as well, that we are, I think we have not released them yet, but eventually, for some reason, they tend to end up being publicly available. So I tend towards the answer that they will be publicly available, but maybe right now not yet. Thank you.
All right.
Hello?
Yes, please go ahead.
Okay, thank you. We already, as I told you, we're on the way to publish a paper. So we are waiting the publication. After that, we will release the data. Thank you.
All right. For the person that asked also, if I can just reiterate, at the beginning, I was sort of introducing the GRAY network, gender responsive AI network. You can also follow them on Twitter, X, and on LinkedIn. They also have a website, you can check it out, Gender Responsive AI Network. Usually you'll find like updates. So for instance, if Dr. Oleni has finally published, the data is fine. You can find them. The last question, and then we can close. I'll hand back the mic to Benjamin. The last question is, all this data has been collected from African settings. Are there any similarities in data collection processes? Is there a possibility of another researcher from another country to make use of these processes? So is it the replicability again of the processes? So yes, anyone can go ahead. What are the similarities in data collection processes? I think I've already seen one, but I'll mention it at the end. What are the similarities, and are the data collection processes replicable? Yes.
Hello, can I say something?
Yes, Dr. Oleni, please go ahead.
Okay, thank you. Yeah, especially in our case, our data set can be a benchmark for all low resource languages because our specific focus is on occupational terms. So this is, almost in all countries, it's the same. The difference is their language. So it can be used as a benchmark. So they can translate for their own language, so the researcher can use it easily. So this is one of the thing, but the process of data collection should be use linguistics as well as the fluent speakers just manually collect. This is the way. Thank you.
All right. Anyone else? What are the similarities in data collection processes, and is it replicable, the process of data collection? Okay. No one else. All right. My last question is on how the community, the African language community, the NLP community in Africa, how can we collaborate to create more inclusive data sets and language resources for these low resource African languages that we're all working for? What ideas do you have? And I'll put this out to everyone on the call, how we can collaborate in making this a reality for our languages. Yeah. Anyone can go?
Hello?
Okay.
Yes, please.
Hello.
Hello.
Okay, so I think one that is really working is these communities. I would say maybe online community like Masakane, where you find a number of people interested, for example, in NLP. I think meeting and really they have organized something that brings together quite a number of people from all over the continent and even beyond. I think collaborations are probably with people from America, Europe, Asia as well. Somehow that kind of establishment has facilitated, work on several tasks, on several data collection efforts. And I think they have been really wonderful resources that have been created. Personally, I've participated on a number of them, but through these platforms, I don't know, maybe it was because of COVID that they really kind of gained a lot of, they had a really great effect. They have really done a lot in leading towards significant resources. So for me, that is one of the main, I think, approaches I see as working towards developing resources for most of the low-resourced languages in Africa. Thank you.
Right, thank you.
Okay, may I add?
Please go ahead, please.
Yeah, beside what he has said, that is very important, but I see two other things. One of the most critical thing I'm thinking of whenever I think about this project and similar projects done in GRAIN is to have, some kind of repository, public repository, so that we can share and collaborate with other researchers, okay, so that we can, put the data in publicly available, okay? So we can set some, policies or something like that, but we have to make the data set available, and which might create, further collaborations and further research. That's one point, data repository. The other one, this research should not stop here. That is one of the critical points I'm thinking. We have to somehow, find out how to, push to the next steps, because these are, very basic. For example, our research, very basic, that can, create so many, opportunities if we think critically and collaboratively. So the research should not stop here. Some may fork, okay, create new ones, or others can merge, and other problems can join. But collaboratively, we have to push forward to the next steps. Thank you.
All right, thank you so much. I want to thank Dr. Walengi, Dr. Ashrat, and Dr. Kengaru for these insights. It's been such a rich conversation, and I hope we can continue having these discussions, especially with the young developers, those that are just starting out in their career endeavors. Again, you can just give GRAIN a follow. If you look for GRAIN on Twitter and LinkedIn, you'll be able to also see these updates that we have going on, and as well as Sunbird AI. Thank you again to IndabaX, yes, for giving us this chance to speak. Yeah, I'll hand over to, I don't know, to Claire, to Benjamin.
Thank you. Thank you. Bye.
Thank you very much, Daphne. I hope you can hear me. And thank you to the Sunbird team, to the GRAIN network. The discussion has really been informative, as well as the session that we had much earlier in the morning. And it really aligns with the theme for this year's IndabaX Uganda, which is around ethical AI. And I know to the participants, this has served an eye-opener, even as we go ahead to apply AI in the various sectors. There are certain things that we need to be mindful of, things around inclusivity. How do we ensure that at the end of the day, the systems or the models that we intend or that we plan to deploy, at the end of the day, they're not going to introduce some form of bias in the society. So thank you very much once again, Sunbird AI, the GRAIN network, and thank you to our participants. So for today, we will close here, and We hope to catch up with most of you tomorrow in the physical sessions that will be happening at Silver Springs. Thank you. Have a good evening, everyone.